Thank you for your introduction. Good morning to all. So our main purpose to assess those in newborns in the intensive care unit was for chest radiographs on a public hospital. Why we did this? Because it's essential to know the doses used in radiology and the radiological protection suitable for each case, reducing the risks arising from the use of ionizing radiation. This is especially important because children are more sensitive to radiation because they have high rate of cell proliferation, increased life expectancy, different body composition, and different functional aspects as faster breathing and heartbeats. This is our methods and materials. This is our equipment, a Siemens Mobilet hybrid, the base unit with the detectors, and the Drager incubator SC. Then we recorded also the exposure parameters and also the distance between the patient and the equipment. And we use these values, these parameters, to calculate the 75 percentile and the entrance surface dose. We also recorded the number of chest X-rays performed on each subject, the weight of the patient, the gestational age, life days at the time of the imaging examination, how long they stayed in the NICU, and also the clinical indication and the name of the radiographer who performed the exam. We divided newborns in 3 categories, as you can see here, from 0 to 1 kilo, between 1 and 2, and more than 2 kilos. Measurements were made with a focus film distance of 1 meter, with and without the incubator, in order to determine the percentage of attenuation caused by the glass of the incubator, which was 5 millimeters. The focus of the radiology equipment with the X-ray beam perpendicular to the incubator at a distance of 1 meter from the detector, and with the exposure values measured, we calculated the ASD by this formula here. So, the relation between the number of children, weight average, and gestational weeks with respectively standard deviation, the majority of the subjects were above 1 kilogram, a small majority of them above 2 kilograms, with an age average of almost 3 kilos. As it was expected, the increase of newborn weight is related to increase in gestation weeks, so we have to adjust the parameters according to the subject's weight. This is our main values for all the sample, with the distance of 1 meter and 1 meter and 28 centimeters, and for the 75 percentile, the same thing. So the average for 1 meter is about 23, and for 75, 23 and 35, so fairly close. This is our results grouped by the weight of the subjects, and has to be expected. As they grow in weight, the dose grows slightly higher. But the average was 24.38 for 1 meter, and 1.28 was 14.88. We always assumed the worst case scenario, so we mainly used this value to compare with other articles and the review of the literature. In conclusion, regarding this sample, resulted from the division of weight in newborns, we obtained an average ASD of 24 micrograys and 28.12 micrograys. From the 75 percentile, also for a focus film distance of 1 meter. We compared the results from the 2 cases, and these values did not exceed the limits required by the European Commission. There was one paper where we had a slightly higher dose, but it was for a small margin. So this study was composed by around 200 radiographs, and we hope to expand it further in the future. Well, I wanted to thank you for your attention, And on behalf of the Medical Imaging Department from the University of Algarve, we hope to see you next year again. So thank you very much.